Hello everybody, welcome back. And we've got another math video coming for you today. Today we're talking about quadrilaterals. Our last video we talked about triangles, three-sided shapes, different types of triangles. We talked about what an angle is, and we talked about how to name different triangles based on the number of sides, what kind of angles they have, that kind of stuff. Today we're talking quadrilaterals. And as I am recording this, there are just a few minor storms rolling through, so you might hear a rumble of thunder. It might not show up on the microphone, but if you do hear a slight rumble, it is some thunder outside. So don't let that get to you. But we've got quadrilaterals. We've got four words that we're going to talk about first. Number one is something that we talked about in our polygon video a while back. And that is just that word quadrilateral. What is it? It's just a four-sided polygon. Okay, it's a four-sided shape that has straight sides and it's closed. That's what a quadrilateral is. Quad meaning four, lateral meaning sides, okay, or sided. So four-sided polygon. A right angle, we talked a little bit about this in the triangle video last time. But it's an angle that measures 90 degrees. And what I want you to imagine, if you're brand new to angles, okay, one thing that we did last time was we drew a little angle like that. That is what a triangle, or what a right angle is. That's what you'd see in a right triangle. One of those angles would have to be 90 degrees. It would have to have room for a perfect little square in the corner. But another way is to think about it as a clock. And I'm going to draw a very bad clock here, but here we go. Okay? That's my best attempt at a circle. So imagine we've got a 12, a 6, a 3, and a 9. Okay? A right angle would be one of the hands pointing up there and one of the hands pointing at the 3. Or maybe it was one of the hands pointing at the 3 and one of the hands pointing at a 6. Or one at the 6 and one at the 9. Or one at the 9 and one at the 12. Okay? That would be a right angle. Okay, 1/4 of a circle, 1/4 of a clock. A whole circle, and again, we'll talk about this later on once we get into angles and all that fancy business, but all the way around a circle is 360 degrees. Kind of seems like a weird number, but that's how we measure a circle. Okay, so if you go all the way around a circle, you measure around the whole inside of a circle, from the top all the way around back to the top, that is 360 degrees. Okay? So a right angle would just be 1/4 of that. If we cut that circle into 4 pie pieces, one of those pie pieces would be 90 degrees. That's a right angle. Again, something we'll talk about later on, but just to kind of show you where that comes from. So a right angle, 90 degrees, that's that little square guy right there. Parallel is another word that we're going to use, okay? And that just means that there are two lines that are going the same direction and they never cross. So, for example, it could be, and we're just going to once again imagine that these are straight lines. Okay? We've got that distance here is the same as right here, is the same as right here. If those lines kept on going and going and going, they would never cross in either direction. Okay, so that is parallel. Two lines going the same direction, they will never cross. Okay, so when we use parallel, that's what we mean. And then a parallelogram is a shape. That's going to be another quadrilateral, another polygon that we did not talk about last time. And that is a special quadrilateral that is made of two sets of these parallel lines. Two sets of lines that will never cross each other. Okay? So there's going to be two lines like that that'll never cross, and then there's going to be two more. It'll look kind of, well, it's going to look just like this. Okay, right here. So we'll talk about that in just a moment here. But that's a parallelogram. Two sets of lines where one set will never cross with each other, and the other set will never cross with each other. So, practice problems. Let's use some of these words. Number one, it has two pairs of parallel sides. Well, number one, it has 1, 2, 3, 4 sides, so we know it's a quadrilateral. but two sets of parallel sides. Now to me, it looks like it's a rectangle. But based on our definition up here, we could call it a rectangle, but I'm going to call it something else. I'm going to call it a parallelogram because based on the description that they gave us, that seems to fit it the best. Okay, based on what they told us about it, that's got two pairs of parallel sides. Right there. That tells us right off the bat it's a parallelogram. Could be a rectangle as well, but it seems to match best with that definition. Okay. Number 2. It is a rectangle with sides of equal length. Now, again, looks like, hey, that could be a parallelogram too, and you could call it a parallelogram. But based on the definition we're looking for down here, a rectangle with sides of equal length. Well, a rectangle is a four-sided polygon that has 4 right angles. But if all the sides of this quadrilateral are the same length, there's a special shape we talked about last time. A special quadrilateral with 4 sides that are all the same length, we call a square. That's a special rectangle. Okay. Number 3, 4 right angles and 4 sides of equal length. Well, guess what? That's also a square. You notice they're the same shape? This one is just rotated so it looks more like a square to us. This one, they turn kind of clockwise or counterclockwise just a little bit. That is also a square. But again, you could technically call it a rectangle, as I have some flashing lights here, once again from the storm. You could call it a rectangle, you could call it a parallelogram, you could call it just a basic quadrilateral. That's up to you, but based on the definition that it gave us, I'm going to call that a square. And then number 4, this is the one that we talked about already. We know this is a parallelogram. Both pairs of its opposite sides are parallel. That one is a parallelogram. Because this set of parallel lines, these lines right here, will never cross. And I'll make our dashes like we usually do. And then that pair of lines will never cross either because they are parallel. It's got 2 sets of parallel lines. These 2 will never cross, and those 2 will never cross right there. And then number 5 down here at the bottom. It has 4 right angles. Its opposite sides are equal in length. So that tells me, okay, that one and that one are the same length. That one and that one are the same length. Using those dashes again. That looks and sounds, based on the description, it even smells kind of like, yep, it smells like a rectangle to me. Yes, I can smell rectangles. You practice them enough, you can start to smell shapes too. That one, rectangles usually have a little bit of a blueberry smell to them. I don't know why. Sometimes mango, but, you know. Anyway, I digress. Number 1 on this side. They don't give us definitions. We're just going to look at what the shape looks like. We're going to give it a name. That looks like we have those 2 the same length. Those 2 the same length. Could call it a parallelogram, but I'm just going to call it a rectangle. Completely up to you. We know it's not a square, though, because not all, 4 sides are the same length. Okay, we got the right angles. We got the 2 sets of parallel lines, so it could be a parallelogram. Kind of looks more like a rectangle to me. Same with number 2. You could call that a parallelogram too. I'm going to call it a rectangle just because it looks more like a rectangle to me. Seems to fit that shape better. Because that one and that one are the same, and that one are the same. Number 3 looks like we've got 4 sides that are the same length, which tells me that one is a square. Number 4, same thing. You could call that one a parallelogram. You could even call it a rectangle. But to me, it looks like that square is just rotated a little bit. seems to look most like a square at that point. This one, we've got one set of parallel lines and another set of parallel lines slightly tilted, kind of kittywampus, a word that is not used nearly enough these days. We got to bring back kittywampus. But it is tilted just a little bit. That looks to me like a parallelogram, as we have more thunder outside the window right now. And then this one, once again, it looks kind of like that first skinny rectangle, but it looks slightly kittywampus. So I'm going to call that one, once again, a parallelogram. And there we are. Now we're going to look at our definitions down here. Number 7, it has 4 right angles and 4 sides of equal length. Well, we know 4 right angles, that narrows it down to, well, it could be a parallelogram too. It could be a square, it could be a rectangle, it could be a parallelogram. That was a big thunder boomer out there. So we're down to those 3 things. However, 4 sides of equal length. Sounds to me the definition best fits a square in this case. Technically speaking, it could be a rectangle, could be a parallelogram, but the 4 sides of equal length do seem to fit the square best out of all 3 of them. Number 8, opposite sides have the same length with 2 angles less than right angles. I'm going to draw that down here. Okay. So what they mean by that is it's something that looks like this. And again, I apologize for my drawing, but what they mean is that opposite sides are equal length, and it's got 2 angles that are less than right angles, kind of like that. Okay, they're not quite that square, they're less than the square right 90-degree angle that we need. That looks to me, when I draw that out, like a parallelogram. So that is exactly what we're going to call it. Number 9, it has 4 sides. Opposite sides are parallel, and there are no right angles. Well, once again, that sounds kind of like what I drew down here. It's got 4 sides. The opposite angles are parallel. Okay? Or opposite sides are parallel, not angles. And there are no right angles. Well, there's no right angles in that one either. Well, we're going to call number 9 a parallelogram as well. With no right angles, that tells me it is not a square, and it is not a rectangle, because rectangles and squares both have right angles, and only right angles. And number 10, it has 4 right angles. Its opposite sides are equal, and all sides are not equal in length. So that sounds like a square with one set of lines or one set of sides longer than the others, which is a rectangle by definition. We'll make that E look more or less like a C. And then we've got one more problem here. Going to make you think a little bit differently. Okay, we want to write the missing numbers in that table. So, quadrilaterals. We know that a quadrilateral has 4 sides. So, what they're telling us is that 2 quadrilaterals would then have 2 times 4, or 8 sides. How many sides would 4 quadrilaterals have? Well, that would be 4 times 4, 4 groups of 4. If we count by 4s, it'd be 4, 8, 12, 16 sides would go in there. Now, how many quadrilaterals would we need to get 24 sides? Well, 24 divided by 4, or we could say what times 4 is equal to 24. How many groups of 4 does it take to get 24? That would be 6 groups of 4. Count by 4s, take 6 of them to get to 24. And our last one, 8 quadrilaterals with 4 sides each. 8 times 4, 8 groups of 4 would get me to 32 sides. Hopefully that makes a little bit of sense. Like I said, some of these, you could put certain ones in there that we didn't write down. there's more than one option with some of these, but try to pick the shape that's going to fit the description best. Okay? To me, personally, that looks more like a rectangle than a parallelogram. It is a parallelogram. You're not wrong if you say parallelogram, but to me that looks more like a rectangle because it looks like it's got 4 right angles. Same with that one. That one is slightly tilted, slightly kittywampus. I'm going to call that one a parallelogram. Okay. Both of those are technically parallelograms, but they look like they've got right angles, and all 4 sides are the same length, so I'm probably going to call those squares over a parallelogram or a rectangle. But hopefully that helps. Hopefully this makes a little bit more sense to you, and that is a little bit more about quadrilaterals. That is not all. There are more types of quadrilaterals that we will talk about later on. We've got the rhombus, we've got diamonds, or a kite, we've got, what am I blanking out on? There's one, trapezoid. Trapezoid's another one. So there are other ones that we're going to talk about, but we're going to hold off on those for a while. But for the time being, that's a good, solid introduction to quadrilaterals. So thank you for watching. If you enjoyed, please drop a like, drop a comment, something to let me know that you're enjoying these and these are helping you. I love hearing feedback, and it helps me know what I can continue to do, what can I change in the future videos, whatever it happens to be. So I will take that feedback and use it. Also, if you are enjoying these, if you have watched other videos, or if you think you want to see more of these in the future, do hit that subscribe button, ring that bell icon right next to it, and then you will be notified when I upload more videos in the future. I'm on a roll. I'm trying to get a whole bunch of them uploaded at the particular moment in time, trying to get a whole bunch on there for summer and into next school year. So there's going to be a lot coming your way if you do subscribe and hit that bell icon. But in the meantime, thank you for watching. I hope you will tune in next time. I think we're going to be moving into some 3-dimensional geometry. We're going to talk about solid figures. All of this stuff that we talked about, triangles, quadrilaterals, polygons, are all 2-dimensional. We're going to add a 3rd dimension. We're going to go even deeper. We're going to get crazy next time. So we'll have a couple videos on that coming up here. Thank you for watching. Stay tuned for that one. Have a great rest of your whatever it is when you're watching this, day, afternoon, night, morning, whatever. And take care.